Hey everybody, this video is about graphing a line using a table of values. Okay, a table of values is an awesome thing because it works 100% of the time as long as we have an equation. So we'll be given an equation. And so here's what a table of values looks like. And this is like this 100% of the time forever and ever and ever. We have a column where we get to choose an x value. Now, it's important that we know that we're choosing this so we don't ask where did that x come from. So I'm going to pick x values that are easy to do math with, such as numbers like -1, 0, and 1. I could make any number in the universe could be over here, but when you times by any number in the universe, things can get crazy. So these are easy numbers to work with, so that's why I'm using them. All right, the next thing is the actual equation. So let's say you were given an equation y equals, 3x plus 2. What we'll do is we'll put that equation, 3x plus 2, right there. That goes there. Always the equation. And then the next spot will be y. Now just watch how this happens here. So first things first, if we choose x to be -1, all we have to do is put that in place of x. So 3, instead of the x, I'm going to put -1. So there it is, -1. And then from here, all we're doing is bed mass, the order of operations. Multiplication happens before addition, so that happens first, -3. And because we didn't touch these, guess what happens? They trickle down. And that's the great thing about math. If we don't touch them, they just trickle down. So -3 plus 2, we know by now, makes a -1. That's all. Okay, I can move this up a bit, I guess. Now, this one, so this is an entirely separate idea now. I'm going to go 3 times x plus 2. So I'm not thinking about this top stuff anymore. But instead of x, I'm going to put in the number 0. So watch what happens. 3 multiplied by 0 is 0. Trickle down, trickle down. Well, 0 plus 2 makes 2. Very good. Let's bring that up there. 3 times x plus 2 again. So we're always starting with this every time. And instead of writing the x, I'm going to put what we chose for x, which is 1. See how easy math that is? 3 times 1 is 3. Trickle down, trickle down. 3 plus 2 is 5. All right, so that is all we're going to do for a table of values for now, is 3 values. But what this means is that when x is -1, our y kicked out to be -1. When x is 0, our y value was 2. When x is 1, our y value is 5. So we're going to show that in this last column, which is a point, okay? You can think of this thing here, this is a coordinate pair, and what it makes is a dot or a point, okay? It's not a distance, it's not, it's not a line, it's just a dot. And it always starts with bracket, some value, comma, some other value, closed bracket. The good thing is there's no calculations to do. We know that the x we chose here was -1, so there it is. We know that the y we found out was -1. It's just a coincidence that they're the same number, no big deal. Going to the next line, when x is 0, our y value was 2. And our next one, when x is +1, our y value is 5. All right, so what we have here is 3 dots. And what we're going to do is put those dots on a graph. One of the things that I look for first as a teacher when someone says, can you check my work, is I look at the y column and I'm asking myself, are the steps the same? Are they the same steps? Meaning, so am I jumping up by the same amount each time? So here I can see I increased by 3. Here I increased by 3. That's the giveaway to tell me that this was done correctly. If this was up by 3 and this was up by 4, then something happened in here with the math that was incorrect. All right, so let us draw this graph. So first things first, we draw our Cartesian plane. Now you just kind of make it so that there's space, you know. You just use the space that you have on your paper, okay? You don't want to cram it down here at the bottom because you're just trying to make it fit. It'll be way too cramped. This is a good size. It's big enough that you can see everything. Now I'm going to just put down my axis lines. So there is my x-axis. So there's my little indicator that it's the x-axis. And there's my y-axis. So I'll put the little y there. And now I'm going to ask myself, what do I actually have? Here I have an x value of -1, 0, 1. So all I need to show on the x-axis is those three values. So would it make sense for me to go like, okay, there's -1, 0, and 1? Would that make sense? Not at all, because it's so clustered together. Instead, what I'm going to do is stretch it out so that it uses the full graph. So maybe I'll put the -1 over there, put the 0 over there. Still, it's always 0 on the line. And then I'll put the +1 over there. So with that being said, now let's look at the y values. So -1, 2, and 5. So clearly we can fit that all in there if we just do single tick marks. Maybe like -1, 1, 2, 3, 4, 5. Well, that's a little clustered there, so I'm going to change that. I'll put it on this side instead. And that's one of the things, we put it on this side where there's space. So that's 5, 4, 3, 2, 1, 0, and that's obviously -1. Now we don't need to write 5, 4, 3, 2, 1. Look how cluttered it gets, so we don't have to do that. So I'm going to just erase that. We don't need that. It's nice to have a few numbers up there just so we know. But if these are unnumbered and that's 5, it would be intuitive that these would each be 1, 1, 1, 1, 1. Okay, so with this being said, let us take these dots and put them on the thing. So again, the x goes left to right. So our x value measures how far to the left or right we are from 0. So here we're at -1. So that means I'm going zip over here -1. And I will have a height of -1. Well, that means the dot will be right there, but it's on my number. So I'm going to change my number I'm going to put it over here, -1. So there's my dot, -1. I'm to the left by 1 unit, and I'm down 1 unit. And yeah, it's okay that these are wide ones on this axis and small ones on this axis. All that matters is that you're consistent per axis, each axis. So for example, the ones can be really small here, and they can be really large on this one. That's fine, as long as I don't have as long as my spacing is even on each axis. So there's my first dot, right there. The next one is I'm neither left nor right, and I have a height of 2. So there will be a dot right there, right there. And the third one is I'll be displaced to the right by 1 and have a height of 5. 2, 3, 4, 5. So something like that. So there's my 3 dots. And then the next stage is you simply just connect the dots. And I'm just freehanding it, so it's going to be a little crooked. You connect the dots. And now you have 6 arrow tips here. Okay, these arrow tips are very important. 1, 2, 3, 4 on your Cartesian plane axis lines. And then an arrow tip on each end of the line that you drew. And the last thing we do is we draw the equation of the line. We're going to name this line so that people know how did this line come to be. And so there is our name right here. Y equals 3x plus 2. So it's just basically saying y equals the function that we dealt with from the beginning to get every one of these points. And that's that. And so right here you have everything you need for a nice simple looking graph. You can see everything, nothing's clustered together. It's not too giant that a person has to look all over the place. You can look at it in one glance and kind of see everything. All right, so that's the first type of table of values question. I'm going to do 2 more just to show you how insane these things can really get. All right, this next question is going to be graph y equals negative 3x plus 5. Now, the first thing we do is we build our table of values. What does it look like? X, and then we show the function negative 3x plus 5, and then we have the y, and then we have the point. So x, y. This guarantees will be the same every time, except for this. This part changes depending on what your equation is that you're given. But this is the skeleton of a table of values. So again, I want to do easy math. So I'm going to pick easy numbers to multiply with. First, I'm going to start with negative 1. So negative 3 bracket plus 5. Now I'm going to put that exact negative 1 right there. That's going to go in there. So negative 3 times negative 1 is exactly positive 3. Trickle down, 3 plus 5 is 8. What's my xy? When x is negative 1, y is 8. Well, that didn't take that much work. Okay, let's try the next one. 0. Negative 3 times 0 plus 5. So I'm using a different color to indicate that that's the x value that we're choosing. So I'm going to put 0 in place of where x used to be. Now I'm going to do the math here. Negative 3 times 0 is 0. We'll add 5, and 0 plus 5 makes 5. So therefore, when x is 0, y becomes 5. Next one, positive 1. Negative 3, I'm just going to use the pink right there. So again, remember, this is where x used to be, but because I'm choosing 1, it's going to be a positive 1 right there. So negative 3 times 1 is negative 3. Trickle down, negative 3 plus 5 is positive 2. So therefore, when x is 1, y becomes 2. Okay? So that's all I'm going to show for the table of values. And now I have 1, 2, 3 points again. So over wherever you have space on your page, it could be below or to the side. You draw a nice big table. You draw a nice big Cartesian plane. I don't know how big to make it because I don't really know what my numbers, where these points are going to be. So first things first, let's look at our x. Negative 1, 0, 1. So I'm going to just set that up again like that. Negative 1, 0, 1. That's kind of how I always start. They're evenly spaced, so that tells me that that axis is okay. As far as the y values, though, 8, 5, 2. Well, those are all positive values. There's no negative signs, right? So because those are all positive, I know they're all going to be on this side. So they're not going to be down here. So if I want to save some paper, I can shorten that up. And I can make this longer if I have space. Nothing wrong with that. Okay. So there's my y-axis. And I used it, made it higher up here because these are all bigger. They're all numbers bigger than 0. And now I can put 8 way up there, which would make 4 there, 2 there, 6 there, 2, 4, 6, 8. I can do that. Do I have to show 1, 3, 5, 7? Absolutely not. It would be obvious that here we're skipping by 2, and we're allowed to do that. There's nothing wrong with that. So now we have our axes set up, and now we can put our dots on the graph. So for example, when I'm 1 unit to the left, I have a height of 8. Okay, so left 1 and a height of 8. So there should be a dot right around there, something like that. So I'm 1 unit to the left and 8 units high. The next dot, I'm neither left nor right, and I have a height of 5. So we have to estimate here. 5 is obviously between 4 and 6, so that's where that one would be. And then our third point, we're 1 unit to the right, and we're 2 units in height. So 1 unit to the right, and 2 units high. There it is. Now that 4 is going to get covered by the line. That's okay. So our last step is we just draw our line, arrow tips on the end of our line. So now I have 6 arrow tips on my graph thing. 1, 2, 3, 4, 5, 6. I've connected my dots, and the last thing is to put the name of the graph on it. So, or the name of the line. So this box, I'll have the name of this line. And if it's kind of, if you'd like, you can even show a little arrow. It says, hey, look, this name of this box, it belongs to this line. It doesn't belong to anything else. And we'll just put that in there, negative 3x plus 5. Y equals negative 3x plus 5. And I can stop it right there. And that would be your 5 out of 5 graph. It has, the steps are even steps. We've gone down the same, we've moved the same distance each time, down by 3, down by 3. That's the first thing. We have our dots, and they're, for a hand-drawn graph, they're reasonably spaced pretty well. This here and this here are reasonably even in spacing. These are even in spacing. 1, 2, 3, 4, 5, 6 arrow tips, and your name of your line there, okay? So there's one more type of question that I'm gonna do, and that's when we have fractions, because we have to know how to do fractions all the time. And so first things first, we don't have to be scared of a fraction. It's the same as anything else that we're doing. Now, I do know that if I have a fraction minus something else here, I might have to deal with fractions. So what I want to do first of all is I'm going to just put that over an invisible 1, because we can. And in my thought cloud, I'm going to say, you know, if I have a 4 and a 1, I should have a common denominator of 4. So what I'm going to do first of all is think to myself, that can be renamed out of 4. And here I just have to multiply it by 4. I get 28 over 4. 28 over 4 is another way of saying 7 over 1. So that's just in my back pocket, okay? I'm just keeping that in mind. So first things first, let's create our table of values. So there's x. Now here's my equation, 3 over 4x minus 7. And here's y. And here is x comma y. So again, the machine stays the same. Same all the time. And then here's our equation. So I'm going to pick some easy numbers for x. Let's try minus 1. So 3 over 4 times negative 1 in place of x. And that comes down, and that comes down. Now this, I just want you to see what's really going on here. This really is saying 3/4 times negative 1. And negative 1 is over a 1, like an invisible 1. So we really have a case of fraction multiplication. 3 times negative 1 is negative 3. 4 times 1 is 4. Trickle down, trickle down. But then I got to deal with this. And this is where I'm going to come back to here. If 7 over 1 is the same as 28 over 4, then maybe I should just start with that right off the bat. Minus 28 over 4. And now I can combine these because they have the same denominator. Minus 3 minus 28 makes minus 31 over 4. Now you can see why I didn't draw my whole table of values at once, right? Next one, we're going to try 0. 3/4 times 0 minus 7. So again, what that means is 3/4 times 0 over 1. 3 times 0 is 0. 4 times 1 is 4. Trickle down, except instead of saying 7, I'm going to say 28 over 4. 0 minus 28 is simply minus 28. So we have minus 28 over 4. Now we're going to do one more. 1. So we have 3 over 4 times 1 minus 7. We remind ourselves that we're really dealing with 3 over 4 times 1 over 1. So we do some bed math. 3 times 1 is 3. 4 times 1 is 4. Trickle down, trickle down. That becomes a minus. Let's change that to 28. 28 over 4. 3 take away 28 is the same as saying lose 28 and then gain 3, which is minus 25 over 4. So there's nothing to be afraid of with these fractions here. I want you to just think of the top number here. let's compare our top numbers. Here I'm warming up by 3 degrees. Here I'm warming up by 3 degrees. So technically I know that my answers are correct. They're evenly stepped. So I'm just kind of ignoring the 4. 31 to 28, that's up by 3. 28 to 25, that's up by 3. So we're good to go. And then we just bring our information over. When x was minus 1, our y was negative 31 over 4. When x was 0, our y was negative 28 over 4. And when x was 1, y was negative 25 over 4. No problem. Now graphing this thing is going to be a little different. So first things first, you just start by graphing, you start by making a Cartesian plane just like normal where you have space. And what we're going to do with this is make our negative 1, 0, 1 thing on it just like normal. So there's negative 1, there's 0, and there's 1. But now we got to look at our y values. Like, what on earth do we do with these things here? First of all, they're all negative. So I know that they're all down here. So what I'm going to do is make that longer. And I don't really need it to be much longer on the top. There's my y, there's my x. Now, okay, 31 over 4. Normally I would have to go like 1, 2, 3, 4, 5, 6, 7, 8, 9, and all the way down to 31, and that would take forever. But I could do that. 2, 3, 4, 5, 6. Okay, negative 6 over 4, negative 7 over 4, negative 8 over 4, negative 9 over 4. Do you see how long this is going to take? It would take so long that we wouldn't have room on our sheet to do. So we're going to do something even better. Watch this. We're going to, oh, by the way, you just imagine counting down like that, right? The fact that we have a denominator is really no big deal. You just tack it on and no big deal. We're going to save some time by taking a shortcut, a legal shortcut. And this is just kind of how I'm phrasing this here. So there's our thing. I know that I have a minus 31 at the bottom, minus 31 over 4. I'm just doing so I have space. There's a minus 28 over 4. And there's a minus 25 over 4. And clearly, going from here to here could not, like, if from here to here is only 3, then from here to here can't be 25. It's way too small. So what I did there, as I said, we skipped a bunch of numbers in here to get to the part that matters. And when you skip numbers, you can show it by making a little lightning bolt. Zzz. It's like a sideways N. That's it. That's all you got to do. Now this is a math symbol to say, hey, look, everybody, there's a bunch of useless information here that we won't need to look at. All the stuff that we need to look at has to do with this data, and this data happened to be way down at the bottom. So by making this little light bulb, we brought that stuff up to the front so we can see it. That's what matters. Okay, now here we go back to our plotting our points. Negative 1, negative 31. There's our dot. Neither left nor right, height of negative 28. 1 unit to the right, height of negative 25. So right there. I'm just going to move that one to the other side. Doesn't matter if these are listed on this side or this side of the y-axis. They're all below 0 is what matters here. So there are my 3 dots. And then just like normal, you draw your arrow tip. Now, I have to put the name of the graph here somewhere, and there's not much room. So what I'm going to do is this. I'll draw it way down here. So y equals 3/4 x minus 7. Put my box around it. And then I'm going to draw an arrow from this box to what it's pointing to. That is the name of this pink line. That's what that arrow is necessary. Otherwise, I mean, does it belong to this thing? Does it belong to this? Is it the start of a new question? We don't know.